So today what we're going to do is we're going to continue looking at the graphs of polynomial functions, and specifically we're going to look at our relative extrema and intervals of increasing and decreasing. So when we talk about a relative extrema, we're including both where the relative maximum or a minimum of a polynomial function could occur, or what you may have also heard of from last year is what we refer to as turning points. So at a turning point is where a relative maximum or relative minimum can occur. So you can have more than one relative maximum or relative minimum. So if you have several turning points, the function can have relative maxima and or relative minima. That's also, like I said, the blanket name we use for both of those is the relative extrema. So if you have a graph where at a turning point, again, you read a graph just like you read a book from left to right, is the value of the function when it is at an up to down turning point. So for example, when you look at this particular graph, I'm going up, then all of a sudden I turn, that's going to be what we consider a relative maxima. So that's my relative maxima. Again, when your graph changes from going from up to down. On the other side, you have a relative minima. If the value of the function, again, we're looking at the y values, is going from down to up. So for example, when you take a look right here, this graph is going down, and then all of a sudden at this turning point it changes, and now my pencil's going up. So at this particular turning point, this is my relative minima. Until you get to calculus, you can't find these 2 points by hand, but you can use your graphing calculators to help you calculate what the points of the relative maxima and relative minima is going to be. So take out your calculator so we can go through how you can find them. So for example, if you're asked to find a relative maximum and relative minimum, you're going to have to use your calculators. So on your calculators, the first thing you want to do is you want to go to your y equals, and you want to enter the equation that's given to you. So I'm going to enter under y1, x to the third plus 3x squared minus 18x. So if I go to my y equals, I'm going to clear out what I have in y1 and y2. So under y1, I'm going to type in the equation that's given, the x to the third plus 3x squared and then minus 18x. Remember, this is a third degree polynomial function, so at most this graph is going to have 2 turning points. So when you go to hit graph, you want to make sure that you see what the relative maxima and relative minimum is going to be. That means you may have to adjust your viewing window. So if you go to window, my window has some very extreme values in it, so what I'm going to do is go back to zoom and hit a zoom standard. What a zoom standard does is it brings your viewing window so that on your x-axis you're seeing x values from -10 to 10. It also does the same thing on the y-axis, so the -10 on the y-axis, +10. As you can see right now, this standard viewing window, the problem is there is a turning point that's all the way up here that I can't see on my graph. There's also a turning point down here. So what we're going to need to do is we're going to need to manually adjust the window. So if you go to the window, because I want to see points higher up and farther down, when I go to my window, x-min means that we want to change your x-axis to be smaller than -10. x-max means we want to make the x-axis go out further past 10. It's the y-min and y-max we need to change. Now what I do is I usually change them in increments of 25. So for example, I'm going to change this y-min to -25, this y-max to 25. So what that means on my y-axis, I'm going to see y values down to -25, y values up to +25. Again, you just hit the window button on the calculator to change these settings, and then I'm going to hit graph. So notice I can see my one turning point down here. So changing my window to a y-min of -25 was small enough. problem is changing that Y max window to positive 25 wasn't large enough. So I'm going to go back to that window. I'm going to make this even bigger. I could do 50. I'm going to go ahead and do 75. There you go. There's more than one correct window setting you can do. But again, the thing you want to be able to see is you want to be able to clearly see where these turning points are located, whatever window setting you're using. So my X min I had as a negative 10. My X max was at positive 10. The Y min I set my calculator to, remember, was negative 25. That Y max I changed to 75. So now let's talk about how you can find these actual points. So here's the instructions. You're going to go under second trace on the calculator. And again, notice in my graph I have a relative maximum and a relative minimum. It doesn't matter which one you choose to do first. So after you go under second trace, if you want to find your maximum, you would choose option 4. If you want to find the minimum, you would choose option 3. So then I'm going to go ahead and do my maximum first. So I'm going to go ahead and choose option 4. Now it's asking you for left bound, and you see you have your blinking cursor. You want to use your arrows on the calculator so that you move your cursor slightly to the left of that turning point. So once it's in good position, hit enter. Notice now the calculator says right bound. Using your arrows, I want to use my cursor to go slightly to the right of that turning point. It's going to ask me guess, hit enter again. So your relative maximum then is occurring, again round to 3 decimal places, at negative 3.646 and 57.041. Now when they ask you about relative maximum, the relative maximum is the Y value. So that's going to be 57.041. The location of where it's occurring at the X value. So it's occurring at X equals negative 3.646. So when they're asking about relative max and relative min, this is how you want to state it. You don't state it as an ordered pair. The relative maximum value is the Y value. So this is the Y value. The location, or where it's occurring at the X values. So now we have a relative minimum. So again, I still want to go under my second trace. Now I want to choose option 3, which is minimum. The calculator is going to ask you the same questions left bound, so you want to move your cursor slightly to the left of that relative minimum, hit enter, and then you need to move it slightly to the right, enter, and then enter again. So now notice they're telling you that the minimum is occurring at the X value of 1.646 rounded to 3 decimal places and negative 17.041. So when you state what the relative minimum is, again, the relative minimum is actually the Y value. So that's your negative 17.041. It's occurring at your X value, and the X coordinate is 1.646. So that's how you state the relative maximum and relative minimum. So here's another example. So what are the relative maximum and minimum of this particular polynomial? So again, I'm going to go under y equals. I'm going to go ahead and clear out the function. And I'm going to go ahead and type in negative 0.5, or you can type in negative 1/2, x to the third, minus x squared, plus 5x, minus 6. Again, remember I've adjusted my window from the last example, so I may need to do some more adjustments. So this is a 3rd degree polynomial function. At most, I can have 2 turning points. Notice on my graph, I actually don't have to adjust my window from the previous problem because I do see those 2 turning points. So remember my settings for my min and max for x and y. The x min was negative 10, Remember, you can go back to your window to look at this. The X max was 10, the Y min was negative 25, the Y max was 75. So, to find these relative minimum and relative maximums, remember, we're going to go under second trace. Doesn't matter which one you find first, minimum or maximum. I'm going to go ahead and do the minimum. Again, you want to move your cursor a little bit to the left of that turning point, a little bit to the right. So my minimum then is occurring at this negative 2.610 and negative 16.97231. So again, if you wanted to sketch this, this is your negative 2.61, negative 16. So my relative minimum is negative 16.972, and it's occurring at x equals negative 2.610. Now to find the relative maximum, I need to go back under second trace, maximum. Again, I need to move that cursor slightly to the left of that turning point, hit enter, move it slightly to the right, hit enter, and then enter again. So again, my maximum is occurring at 1.27 and negative 2.28. So my maximum is the Y value, negative 2.287, and that's occurring at x equals 1.277. And again, the sketch of this graph would look something like this. So that's how you can find the relative maximum and relative minimum using your calculators. Like I said, until you get to calculus and you learn derivatives, you're not going to be able to find these points by hand. So when you're talking about relative maxima and relative minimum, or your relative extrema, we also can talk about absolute maximum and minimum. An absolute maximum is occurring, again, it's occurring at a turning point, or a relative maxima, and you're looking at where the largest Y value is going to be. While a local maximum occurs at an X value where the Y value is larger than other points around it. So in other words, to be an absolute maximum, that's got to be the absolute highest point on the graph. Absolute minimum is occurring a point on the function where it's the smallest Y value. Again, a local minimum occurs at an X value where the Y value is smaller than other points around it. An absolute maximum or minimum can occur at a relative extrema, or it can occur at an endpoint if it's a closed interval, if you're not dealing with a domain of all real numbers. So here's an example of the difference. Notice right here, the absolute maximum. When you take a look at this entire polynomial function, this is the absolute highest point on the graph. There is no part of the graph that goes above that point. So we call this point an absolute maximum. And then again, notice the graph goes down. You have a relative minimum right here. But notice, this is not the lowest point on the graph. The graph is going all the way down to infinity. So we would say that this graph has no absolute minimum, because the graph doesn't have a lowest point because it's going down to infinity. So notice this one has the highest point versus no lowest point. You do have a relative maximum and relative minimum. Notice the relative minimum occurs at the turning point where it changes from going down to going up. And then you do have a relative maximum at this particular point where the graph is changing from point going up to down. So once you find these particular values, we can talk about intervals as increasing and decreasing. We say that a function is increasing on an interval if the function Y values increase as the input values increase within that function. So for example, your graph is going up. So if you trace your graph and it's going up, we say that it's going to increase. Similarly, a function is decreasing on an interval if the Y values are decreasing as the input values increase over that interval. So we would say that this would be decreasing. So for example, notice, again, you read a graph just like you read a book. read from left to right. So notice, as I trace this graph, my pencil is going up. So I would say that that particular interval is increasing. When you're stating values of increasing or decreasing, you always state the x values using parentheses. So we would say that I'm going to be increasing coming from negative infinity, because notice that I am going from negative infinity up to this particular x value of -2. Then notice, once I go through this turning point, my pencil starts going down. So I say that that particular interval is decreasing. So it's decreasing from -2 to +2. Then notice, after I pass through this particular turning point, my graph starts to go back up. My pencil, as I trace it, goes up. So then I'm going to say that this interval is also increasing from 2 to infinity. So to find your extrema and the intervals of increasing and decreasing, so for example, let's take a look at the relative maximum. The relative maximum is occurring at a turning point that changes from increasing to decreasing. Remember the way you state a relative maximum? You state the y value, which in this particular case is 6, and that's occurring at x equals 0. Because again, you know that this point is occurring at 0, 6. But the way you state a relative maximum is the y value, the location is the x value. You have a relative minimum. And again, if you look at this particular point, you know that this is occurring at -6, and then the y value is -1, -2, -1, -3. So we would say the relative minimum is -3, and that's occurring at x equals -6. So now when you take a look at intervals of increasing, if I was to and decreasing, if I start tracing my graph left to right, notice this pen is going down. So I know that that interval is going to be decreasing, and it's decreasing from -infinity. Remember, you use the x values to -6. Then notice my pencil changes. It's no longer going to go down, it's going to go up. So that is my interval of increasing. So that's going to be from -6 to 0. Then notice my pen passes through that turning point and it goes back down. So I have another interval that's decreasing, and that's going to go from 0 to infinity. So now to find the absolute maximum and minimum, I want to find the absolute highest point or lowest point on the graph. Notice this particular graph does not have a highest point because it's going to infinity. This one does not have a lowest point because it's pointing towards -infinity. So there is no absolute maximum, there is no absolute minimum. So now let's take a look at one where we're going to actually have to, the graph isn't given to us. So this is where we're going to go ahead and take a look at this on the calculator. So I'm going to go back to my y1. I'm going to type in -2x squared plus 12x minus 16. Now my window I've really readjusted, so I'm going to go back and bring it back to a standard viewing window. So to do that, I'm going to go to zoom 6. That'll bring my x and y axis out to -10 and 10. So it is a quadratic, notice. So it's a degree 2. So I know at most I'm only going to have one turning point. So notice the only turning point I have right here is at that particular point. So to find this particular point, I'm going to go under second trace maximum. Move that cursor slightly to the left, hit enter. Move it slightly to the right, hit enter, and it tells you exactly where it wants it in the corner. So sometimes they calculate 2.99999. When you round that up, it's going to be at 3.2. So that's what this graph looks like. So now notice that I do have an absolute maximum. That is the highest point on this particular graph. So the way you state absolute maximums and absolute minimums is exactly the same way as you do relative minimums and relative maximums. So my absolute maximum y value is 2 at x equals 3. Notice this graph is going down to negative infinity, so there is no absolute minimum. Notice I do have an interval of increasing. Notice when I read this graph left to right, I'm increasing from negative infinity to 3. Remember, you always use x values when you're talking about increasing and decreasing. Then notice my pencil goes down, and that's going down from 3 to infinity. I only have this one turning point. There is no relative minimum. However, the relative maximum, you have the absolute maximum occurring at 3, 2. You also can consider this a relative maximum as well, which is 2 at x equals 3. So let's take a look at another one. X to the third, go back to your y equals, x to the third plus 9x squared plus 24x plus 22. Again, my viewing window is set from negative 10 to 10. So now this is a third degree polynomial, so I know at most I'm going to have is 2 turning points. So notice I've already seen the 2 turning points, so I don't need to readjust my window. So notice I've got a relative maximum and a relative minimum. So to find those points, I'm going to go to second trace. I'm going to go ahead and do the maximum first, option 4. So remember, I need to move my cursor so that it's slightly to the left of that relative maximum. Then I'm going to move it to the right of that relative maximum and then hit enter. So notice my relative maximum is occurring at negative 4, 6. So to sketch the graph, so the relative maximum, remember, it's the y value of 6, and it's occurring at x equals negative 4. So now to find the relative minimum, I'm going to go back to second trace, move my cursor slightly to the left of that point, hit enter, move it to the right, and then enter again. So notice this point's occurring at negative 2, 2. So the relative minimum, remember, it's the y value, and it's occurring at x equals negative 2. So this graph looks something like this. So now my intervals of increasing and decreasing. Again, when I read this graph, I always start on the left. So notice my pen is going up until I hit negative 4. So I'm going to state my interval of increasing from negative infinity to negative 4. And then notice when I pass through my relative maximum, my pencil no longer is going up, it's going down. So I would say that I'm decreasing from negative 4 to negative 2. And then my pencil, as I trace my graph, goes back up. So I know it's going to be increasing from negative 2 to infinity. Remember, to be an absolute maximum or absolute minimum, you have to have the highest or lowest point on the graph. Because this end behavior, I'm going all the way to positive infinity and negative infinity, there is no absolute maximum, there is no absolute minimum. Remember, they have to be the highest and lowest points on the graph to have one of those. Now, there was a page that was left out of your notes that, if you want to take that out, last thing. And that is being able to write a polynomial function given these conditions. Now, when you want to write a polynomial function, if I give you the zeros, what you need to simply do is write the factors. But the problem is, what we're going to have to find is the leading coefficient. So when you're trying to write these polynomial functions, you've got to find that leading coefficient. So we know, for example, that this particular function has a degree of 3. They're giving you a point on the graph. P of 1 is equal to negative 4. So I know I have this point on the graph. They're giving me my zeros. I know this graph has a 0 at -1 with a multiplicity of 2. So remember what that means is this is going to touch. I also know that this is going to have a 0 of 3. So what I'm first going to start to do is I'm going to start to write this particular polynomial function in factored form. So again, what I'm going to have to do is eventually find a, because if my leading coefficient is positive versus negative, it affects the end behavior. That's why we're going to need to find what this leading coefficient is. So again, my 0 is -1. The factor that -1 came from is x plus 1. So I'm going to write this equation in factored form, and my factor is x plus 1. My multiplicity is 2, so that means that the exponent for that factor is 2. The 0 is 3, which means the factor this came from was x minus 3. So in my equation, I'm going to write my factor of x minus 3. So then to find a, what you're going to have to do is plug in the x value of the point they're giving you, plug in the y value of the point they're giving you, and solve for a. So I'm going to take -4 is equal to a times 1 plus 1 squared times 1 minus 3, and solve for a. So -4 is equal to a times 2 squared is 4 times 1 minus 3 is -2. So I have -4 is equal to -8a. And then when I solve, a is going to be equal to 1/2. So I can finish writing my equation. P of x is equal to 1/2 times x plus 1 squared times x minus 3. So now, since this is a third degree polynomial function, my leading coefficient is positive, I think about what the general shape is going to be in terms of the end behavior. I know left side's going to go down, right side's going to go up. Remember, because at -1 I have a multiplicity of 2, I know that this graph is just going to touch the x-axis at -1. So again, I know it's going to come up, touch, it's going to come down, pass through that point, and then come back up at 3. So now, the next example, they're giving me that this polynomial is a degree of 4. They're giving me my point on the graph of -3, -6. They're telling me I have a 0 at 1, and my multiplicity is 2, so I know it's going to touch. At -2, I also have a 0 that's also going to touch. So in factored form, again, I don't know what that leading coefficient is, but since my 0 is 1, I know my factor is x minus 1. The multiplicity is 2, so I know that exponent is 2. I have another 0 at -2, so that means that that factor is going to have to be x plus 2. And again, my multiplicity is 2. So I have to plug in the point they're giving me, which is -3 for x, -6 for y. So -6 is equal to a times my x value is -3, -3 minus 1 squared times -3 plus 2 squared. So -6 is equal to a. Again, this is -4 squared, which is 16. -3 plus 2 is -1 squared is 1. So -6 is equal to 16a. When I divide by 16, a is going to be equal to, again, I can divide out of 2, which is going to be -3 over 8. So my polynomial function is going to be p of x equals -3/8 times x minus 1 squared, x plus 2 squared. Now, I have an even degree polynomial function. Notice my leading coefficient is negative. So remember what happens, both ends are going to have to go down. Remember, at -2, I'm going to touch. At 1, I'm also going to touch. I'm going to pass through this point, -3, -6. So it's going to come down, go up, come back down, and that's what this polynomial function is going to look like. So my last one, they're telling me I have a degree of 5. Again, they're giving me that point 0, 2. Again, they're giving me my zeros. of -4, -2, 1, and 3. So they're giving me this point 0, 2. I have a 0 at -4. I have a 0 at -2. I have a 0 at 1, and then another one at 3. And notice at 3, this is where I'm going to touch. So my polynomial function then, again, I have to find that leading coefficient. My 0 is -4, so the factor that it came from is x plus 4. My 0, -2, excuse me, came from the factor x plus 2. My 0 of 1 came from x minus 1. My 0, 3 came from the factor of x minus 3. So now to find the leading coefficient, I have to plug 0 in for x, 2 in for y. So 2 is equal to a times 0 plus 4 times 0 plus 2 times 0 minus 1 times 0 minus 3. So 2 is going to be equal to a times 4 times 2 times -1 times -3. So 4 times 2 is 8. 8 times -1 is -8. -8 times -3 is going to give me a positive 24, a. So a is going to be equal to 1/12. So now I can plug that back into my polynomial function. Oh, don't forget this x minus 3 has a multiplicity of 2, so there's that 2 power. So I have 1/12 times x plus 4 times x plus 2 times x minus 1 times x minus 3 squared. I have an odd degree polynomial function. My leading coefficient is positive, so think about what your end behavior is going to be. I know that the left side will go down, the right side will go up. Again, I'm crossing at each x-intercept except at 3 where I'm going to touch. So I know I'm going to cross here, So, guys, I realize I accidentally calculated the wrong leading coefficient. I apologize. I forgot this 2 originally. So 0 minus 3 squared, that should give me a positive 9 because -3 to the second is 9. So when I calculate the a value, 4 times 2 is 8, 8 times -1 is -8, and -8 times 9 is a -72. So a should be equal to -1 over 36, which makes a big difference because my end behavior, left side goes up, right side goes down. So I still have my x-intercepts at -4 and -2. And again, remember, I have to pass through this point 0, 2. But now remember, I'm going to cross at -4, come down, cross at -2, pass through that point 0, 2, cross at 1, come back up, touch at 3, and then turn back down. So that's what this particular polynomial function should look like.